4-3, Part 2, more about writing and graphing functions. Now you're still on your note pages 53 and 54. None of the stuff we're going to do in this video is actually on any of those pages, so you can be back there on 53 below the vertical line test stuff, or in that big space on page 54 below there. If that's not enough room for you, binder paper is fine also. Let's start. Just a reminder here about domain and range. Right? When you look at the graph of a function, it helps you determine the domain and range. And a lot of functions are going to have all real numbers for the domain and range because they go on forever in both directions. If you think about what a line looks like, just a regular old diagonal line, the domain and range are going to have to be all real numbers because, this line eventually touches every x value. It goes on forever in the x direction, both positive and negative, and it's going to keep increasing forever and keep decreasing forever on the y-axis. So all real numbers. Not all of them will be, but a lot of them. So if you're forced to choose when you're not sure, that would be a good guess. Let's look at a couple examples. I think this first one is a lot like what we were just saying. Here's the function, y equals 5x. You're going to sketch it. Probably go ahead and pause the video while you do that. Now that you're back, you've got your video, you've got your sketch, and y equals 5x is there. But when you look at it, all the y values are going to appear somewhere because it keeps going up, 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 and down, 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 down forever. And all the x values are going to have to appear somewhere because it keeps getting bigger and bigger and wider and wider and wider. So for y equals 5x, the domain is all real numbers. And the range is all real numbers. Because it's going to touch everything eventually, That line keeps going and going and going infinitely. Let's look at another one. Now this is a little bit different. Go ahead and sketch it. This is the function y equals x squared. It is a function. This is a parabola. We'll learn lots more about these later in the year. Now that you have it sketched, let's take a look at what's happening here. For the domain, you can see this parabola, as my pen traces it, keeps getting wider and wider and wider. So as it keeps going up, 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 it's going to keep getting bigger and bigger and bigger and bigger and bigger. So eventually it could touch every positive x value and every negative x value. So the domain in this is still all real numbers. But the range is not, because here's the bottom of the parabola at 0, y equals 0. And it goes up forever, but it does not continue down into the negatives. So that means we can write this as an inequality, another use for inequalities. And it's going to start at 0 and keep going up from there. So the y values need to be greater than or equal to 0. So not a list of points because it's a continuous function, but instead an inequality showing that y is greater than or equal to 0. Anything bigger than 0 is part of the range. If it was turned upside down, and looked like an umbrella instead of a smile, then it would be y is less than or equal to 0 if it was at that same place. Just a quick review here of independent and dependent variables. I know we just did this, but reminding you that the value of the dependent variable is a function of the independent variable. The independent variable, this is the one that you choose, and the dependent variable is the one that you calculate. Now that's important because we're going to take a look at a couple word problems. That's a C. Write the problem down. A lawyer's fee is $250 per hour for her services. And your job is to identify the independent and dependent variable and then write the function rule. So this is putting together what we did in the first half of this lesson the other day, but with word problems now. Lawyer charges $250 per hour. So what are we going to plug in to calculate how much it costs? Well, we're going to plug in the hours. That's the independent variable. That's the one, right, where we're choosing what we plug in. We can plug in what if she works 2 hours or 10 hours. The dependent variable is the total cost, right? Not the fee per hour, but the total cost. Okay? Try to use variables that make sense. So I'm going to use h for hours. Okay? So the function is of the cost is the hours. So we take the hours and it's $250 per hour. So we multiply by 250 by h. So it's f of h equals 250h. On the quiz, I will ask you to specifically identify in words what the independent and dependent variable are. So be prepared for that. We're going to do one more of these examples. And I think that's almost it, actually. This is a pretty short lesson, but it was a little too much to cram all into one. Same game. Okay, write the problem down. Pause it if you need to. A fitness center charges a $50 initiation fee plus $40 per month. Okay, $50 initiation plus $40 per month. And we're trying to figure out, basically, right, how much does it cost to belong to the fitness center? Well, all right, so if we're trying to figure out how much it costs to belong to the fitness center, that must be the dependent variable. That's what we're trying to figure out. Cost to belong. Okay. And the independent variable is based on how many months were there. Okay, so that would be the independent variable, the number of months. Let's use m. The independent variable is the one that always goes in the parentheses, right? And we're going to say then they charge $50 flat fee plus $40 per month, so 40m. And that's really it. You're not being asked to figure out any data points for this yet, but if you're thinking, hey, maybe that's where this is heading in the next chapter, you're right. That's where we'll be going with it. And I think we're at the end. Let's see if it'll flip to the next page. I don't think there's any more examples unless I'm not remembering. Nope. That's it, guys. See you soon.